Hello all. Today we discuss about serial input output and data communication for 8085, and this concept is used for any microcontroller like a PIC, EVR or 8051 microcontroller, and also for the advanced RISC machine ARM7 ARM9 architecture. So basically serial input output data communication, there are basically needed some transmission format. So a transmission format is concerned with issues such as synchronization, direction of data flow, speed errors, and medium of transmissions. Okay, so first of all, our topic is transmission format. So what is a transmission format? We just talk about that. A transmission format is concerned with issues such as synchronization process, direction of data flow, speed errors, and medium of transmission. So basically there are two different types of transmission process are available. One is synchronous and another is asynchronous. So number one is synchronous and number two is asynchronous. Okay, serial communication occur in either synchronous or asynchronous format. Any one can be used. In the synchronous format, receiver and transmitter are synchronized. That is, a block of character is transmitted along with the synchronization format, and this format is generally used for high speed transmission for 20 kilobit per second. And asynchronous format is a character oriented. Each character carries the information of the start and the stop bit. When no data are being transmitted, the receiver state at logic 1. Student, please note that in asynchronous transmission, when no data are being transmitted, the receiver stays at a high logic 1, which is also known as mark signal. Logic 0 is called space signal, and that means receiver stay at a logic 1 called mark, logic 0 is called space, and this is called the mark space. This term is used for the frequency shift keying. When transmission begins, there is a format follows. When transmission begins with one start bit, which is low, followed by a character and one or two stop bit, and this stop bit is a high, logic high. This is also known as the framing format, and these should be either 10 or 11 bit for an ASCII character in a asynchronous format. I again repeat, in a frame there contain one start bit, 8 character bit, and 2 stop bit or 1 stop bit. If 1 stop bit, then 1 start bit, then start bit is a 1, which should be low, then 8 character bit. Here we place our character, any value, either voltage, current, any kind of character which is transferred from peripheral to microcontroller or processor, any kind of, and 1 stop bit or 2 stop bits. So if 1 stop bit, so there are 10 bit are used, and 2 stop bit, so there are 11 bits are used. Okay, so this is the first process of synchronous and asynchronous. So what about the synchronous process? If we consider this is a transmitter, TX means transmitter, and this is the receiver, RX means receiver. So in a synchronous process, there is a main clock is connected to this, and here if we plot time, and here is the data packet that is synchronous. So this is our data format. So this clock and this clock are connected to this main master clock, and data should be communicated in the same clock cycle. But in the asynchronous transmission, there are some different hardware requirement. This is TX, and this is running by one clock, and this is RX, this is running by another clock. So these two clock are not synchronized to each other. That's why here we needed our frame sequence. This is first start bit, this is our start bit, and 8 low bit, this is 8 character bit, and high bit 1, that is called stop bit. So first of all, start bit is low, and then 8 character bit, and this character bit also known as our data, and then one stop bit. And that's why in asynchronous transmission, as if the clocks are not synchronized, so using this starting bit low, receiver can determine the next character will be coming from the transmitter. And high bit means one stop bit means there is no further character is transmitted. Okay, so using the communication purpose, there are basically three types of communication are possible. One is simplex transmission, that is data transmitted only one direction. Duplex communication, data flow in the both direction. And full duplex means generally transmission of the two microcontrollers or microprocessor or between the computer and terminal is a full duplex. This is type of full duplex communication. If both ways goes simultaneously, that means transmitter and receiver both are the data transmitted in a simultaneously pattern, this is called the full duplex. But when if transmission goes one way at a time, it is called the half duplex communication. Okay, now we discuss about rate of transmission. Our next topic is rate of transmission or speed of transmission. So this is very important. Generally this is this parameter is denoted as a baud rate. So basically it is a very common factor. So rate of transmission is depend on the number of bits per second, and this is also called the baud rate. Okay, so either logic 0 or 1 can be sent. So if we consider there 1200 bits are transmitted 1 second, so for 1 bit 1 by 1200, that is 0.83 millisecond are required. Okay, that's how we can determine our rate of transmission. And there is also another bit is used in this serial transmission, which is known as parity check, but not all time we can introduce the parity check in the serial data transfer. The parity check bit is basically used for during transmission various types of error can occur. For example, data bits may change because of noise or can be misunderstood by the receiver because of differences in the receiver and the transmitter clock. So these errors need to be checked. Therefore, additional information for error checking is sent during transmission. The receiver can check the received data against the error check information, and if an error is detected, the receiver can request retransmission of that data segment. These methods are generally in common practice. They are parity check, checksum, and CRC, that means cyclic redundancy check. Okay, so during the 1-bit transmission error or multi-bit transmission error, there are special kind of CRC or 16-bit CRC, 32-bit CRC, 8-bit CRC. There are different polynomial are used for the to check the error and also corrected the error for the reliable transmission. That is, there is no error in the serial data transfer from transmitter to the receiver end. So this is the basics fundamental discussion of serial data transmission, and what are the parameters and what are the logics and what is the mechanism how serial data is transferred from transmitter to the receiver end. Okay, so here we again repeat one thing: the serial bit format for ASCII character in asynchronous mode. First of all, this is known as the marking. This is a marking, and here first start bit equal to low. Okay, then this is the first bit D0, and say consider after some time this is start bit, this is should be low, this is D0, this is D1, D2, D3, D4, D5, D6, D7, and this is D8, this is D8, and after this is must be should be 1, because these bits should be represent the stop bits. So this is contained in a one frame. That means 10 bits are required to transmit one character from transmitter to receiver. Or in the receive purpose, this format is also for the any data is received. This format is also used. So depending on upon how this generate, the baud rate can be different. Generally, the common baud rate in a serial IO transmission is used is 9600 baud rate. There is also different types of baud rates are available, say 115, 11520 baud rate. Generally 9600 baud rate is a very common, and there is also high speed for high speed communication 11520 bits per second are also used for this serial IO data transmission, and it depends on the microcontroller hardware facilities and the peripheral facilities also. So in this lecture we just talk about the serial data transmission, how serial data are transmitted, what is the packet format, what is the frame format, also known as the packet format. Okay, what is the different transmission mechanism, synchronous and asynchronous, and what are the difference between them. Okay, and then we talk about the basic sort and then we basic talk about the different types of format. Okay, say 10-bit format or 11-bit format.